turn our attention to partial orders. A relation R is said to be a partial order if and only if it is reflexive, antisymmetric, and transitive. Let's look at an example. So let X be the less than or equal to relation defined on the set of real numbers such that for all X and Y in R, which is a set of real numbers, X is related to Y if and only if X is less than or equal to Y. And we need to show that this is a partial order. Now remember, a relation is a partial order if it satisfies these three properties. So we need to show each of these properties individually. So we start off with reflexive. Now recall, by definition, a relation is said to be reflexive if for all, let's say, X in the set of reals based on our set, X is related to X. So in this case, we use capital X to represent the relation. Now, the only way that this relation will be reflexive is if for all X in R, X is related to X. Alright, now X being related to X implies that according to the definition of the relation, X is less than or equal to X. Well, so X is less than X or X is equal to X. Now, by the laws that govern real numbers, we know that a real number will always be equal to itself. Therefore, X will always be equal to X, and this tells us that X will always be related to itself. Therefore, our relation is reflexive. The next property is the antisymmetric property. Now, if you recall from earlier in the video, then the antisymmetric property says that for all X and Y in R, basically we can say if X is related to Y and Y is related to X, then X must be equal to Y. So what we're going to do is we are going to assume that both of these are true. So let X be related to Y. This tells us that we have one of two things. Either X is less than Y or X is equal to Y. We're also going to let Y be related to X. And this also tells us two things. It tells us that Y is less than X or Y is equal to X. Now remember, we need both to happen. We need X to be related to Y, and we need Y to be related to X. Now if X is related to Y, it means that X is less than Y or X is equal to Y. If Y is related to X, it means that Y is less than X or Y is equal to X. Now, the only way that both of these are possible, because it is important for x to be less than y and y to be also less than x, right? So the only way that this is possible is if x is equal to y. X being equal to y is the same as y being equal to x. So the only way that these two are possible is if these two are equal. So therefore, this relation is anti-symmetric. Next up, we have the transitive property. Now recall, with the transitive property, we say for all x, y, and z in R, if x is related to y and y is related to z, then x must be related to z. So we're going to take these two as a given and show that this must happen. Alright? So let x be related to y. This tells us that x is less than or equal to y. And we're going to let y be related to z, which tells us that y is less than or equal to z. So since these two are given, we have x is less than or equal to y, which is less than or equal to z, which tells us that x is less than or equal to z, which tells us that x is related to z. Therefore, transitive. Now, since all three properties hold, we say that this is a partial order. So since x is reflexive, antisymmetric, and transitive, it is a partial